Right, if there's anyone that's forgot about the lesson today, just let them know, because this is quite an important one. There's quite a few tricky bits in here today. There's quite a lot of key concepts that you need to take in. So today what we're going to do is look at inverse functions. So we'll start it quite simple, but we will get into some quite complicated examples, especially when we're looking at range and domain a little bit later on. Now, firstly, let's just look at what an inverse function is. So it's just a reverse mapping. So basically doing the opposite. Okay, so if you've been using inverses all throughout maths, of course, you know, times and divide, e and natural log, for example. So what we're going to do is look at how we can take a function that then, if we want to go back to the original domain of what we're putting in, we've got that function that we can do that. Okay, that's going to be our f to the minus 1. So here we've got two different sets, and we can see there's a rule that takes the numbers from set A to set B. Okay, so it takes numbers from our domain to our range, and that's going to be 3x minus 1. So when we use 3x minus 1, what essentially we are doing, we take the x, we times it by 3 to make it 3x, and then we take away a 1 from it. That makes it 3x minus 1. Okay, the order is important there, because obviously if I take away the 1 first and then times the 3, that would be something different. Now, if I want to go backwards, so if I've got any numbers in my range and we'll go back to what it originally was, I'm going to have to add the 1, and then that will just give me 3x, and then I will just divide by 3. So if I want to go back, what I have to do to a value of x is I have to add 1 to it and then divide by 3. So if 3x minus 1 is my function, my inverse function is x plus 1 over 3. And you can also check that this is what happens with any elements in your domain to go to your range. If you take 2, for example, times it by 3, and take 1 from it, you get 5. To go back, though, you'd have to add 1 to that and divide by 3 to get back to the 2. Okay, so your elements in your domain should be mapped to the elements in your range, and then this inverse function maps them back to the domain. In general, what we want to do when we're finding an inverse function is we want to say let y equal f of x. Okay, sometimes it might be g of x, h of x, etc. So we let y equal f of x, and then what we do is we make x the subject. So we're going to just have an equation, y equals some function of x. We're going to make x the subject, and then what we're going to do is we're going to replace the y with an x, and then we're going to replace the x with a f to the minus 1 of x. So just showing this quite simple example here, we would have started off with y equals 3x plus 1. We then rearrange it to make x the subject, so we'd have x equals y plus 1 over 3. I would then change the x to f to the minus 1, and then I would change the y to an x. Okay, and that's what we got there. So simple ones like this, you can probably just write it down straight away, but we're going to see some slightly harder ones as we go along. So with that in mind, we're going to look at our first example. So firstly, I'm going to let y equal f of x. So I'm going to start off with y equals 5x minus 2 over 3. I then multiply both sides by 3. Add 2 to both sides. And then divide both sides by 5. Okay, I'm making x the subject. That's not quite it though. You'd lose the final mark if you just left it like that. What we then have to do is change that x to an f to the minus 1 to show that I'm talking about my inverse function, and then I just change the y to an x. And then that is my inverse function. So you can see there, the y has gone to an x, and the x goes to that f to the minus 1 over x. So hopefully so far, nice and straightforward. But do let me know if there's any questions that you've got. Example 2. We've got f of x equals the square root of x minus 2. So the first thing I'm going to do is I'm going to sketch what this looks like. Now, before I do so, I'm going to consider what the domain is here. Okay, so I know that x can be any real number, but there is a restriction on it. Can anyone tell me in the chat what restriction I would need to put on x so that it can be a function? Remember, to be a function, it has to be defined for all elements in the domain. Okay, excellent. And you've got the equals in there as well. So yes, x is greater than or equal to 2. Yep, I can see other people with greater than or equal to 2. Okay, so we need to put that in here. I'm glad that you both put greater than or equal to. Sometimes people just put greater than 2. Remember, you can square root 0. That's fine. So this would just be my sketch of f of x here. Now let's find f to the minus 1, or the inverse function. So set this as y equals square root of x minus 2. Now I want to make x the subject, so I need to isolate the x. What I would do is I want to get rid of that square root. So to get rid of the square root, I'm going to have to square both sides. Okay, square the left-hand side. So when I square the whole of the right-hand side, it just gets rid of that square root. Then what I would do is just simply add 2 to both sides. Then just change the x to an f to the minus 1 and change your y to an x. And you get the following. So then if I draw this, I now get my f to the minus 1 of x. And also, you can see there, I would have a y-intercept of 2. So just in the chat again, so we're asked to comment on our findings. So just write down your thoughts, anything you noticed there about those two graphs. You might notice something else if you drew them a little bit more accurate than I did possibly. But anything we notice about those two graphs? They won't meet, that is true. Yeah, they won't meet. The graphs won't intersect, that's correct. And then also there are some people saying that they're reflected. In particular, reflecting line y equals x. So yeah, these graphs will not meet. And they're also reflected in the line y equals x. So reflecting the line y equals x. So these are, so this is it's going to be really important fact that we're going to use quite a lot when we're doing our sketches. Now, there's also something else that we might notice. If we look at the range of f to the minus 1, what we should notice is that f to the minus 1 x is greater than or equal to 2. If I look at where my graph starts here, okay, it's just greater than or equal to 2. Now I can't draw it more of the graph to the left of this minus 2 because I need to consider what values were in my domain in the first place. Okay, so if I look at the range here, I should notice that it's the same as my domain, which is going to be quite an important thing that we look at in a second. So let's do another example and see if we spot anything similar. So example 3, we've got f of x equals 3x plus 1. and we've been given the domain this time. So I'm going to start off by drawing that line. So you've got f of 3x plus 1, which is going to look something like this. Okay, it's got a root there at minus a third, and it's got a y-intercept at 1. However, if I look at the domain, actually, let me just readjust that. Then I just want to draw it like this, okay, because the domain is just between minus a third and 2. So we're going to say that x equals 2 is here. So this is the graph, okay, and the domain's been restricted, so it's just going to go between these two values. And if we're finding the range of f of x, make that clear, range of f of x, then we can see that it goes between 0 and then when I put in x equals 2, I'm going to get my greatest value. So when x is 2, I get y is 7. So this is just going to go between 0 and 7. Next, what we're going to do is find the inverse of this. So start off with y equals 3x plus 1. Rearrange this, got there eventually. Rearrange this to make x the subject. Change the x to an f to the minus 1 and change the y to an x. Okay, so just x minus 1 over 3, or if you want to split it up like I've done there, it's just a third x minus a third. The reason why I did that is just so I can simply see my y-intercept there. I mean, it's quite easy anyway, just put in y equals 0, but we could then see that it will look something like this, where it's going to have a root of 1, and you're going to have a y-intercept there of minus a third. And this value here, well, we should find it's going to be 7. Okay, because of what the domain is. Okay, I can only go up to 2 here for my f to the minus 1. So what that means is when I put in f to the minus 1 as 2, when I solve that, I'd get x as 7. So what we should notice here, the domain of this is that x is any real number, and it goes between 0 and 7. And as I mentioned before, that's because f to the minus 1, it can go from minus a third to 2. So in order to get that minus a third, I put in x as 0. To get that 2, I put in x as 7. And then the range of this, well, it just goes between minus a third up to, as I mentioned, 2. Okay, yet again, we have that reflection in the line y equals x. So the key points here is yet again, we've got reflection in the line y equals x. And what we also might start to notice is that the domain of f of x is the same as the range of f to the minus 1x. Oh, sorry, wrong thing. So the domain here is the same as the range here. The only thing, obviously, it's different. It's just the notation. When I'm talking about my domain, I'm always using x. When I'm talking about my range, when I talk about the range of the inverse, make sure you put f to the minus 1. Don't just put f to the x here. It's really important. That's f to the minus 1. Also, what we should notice is that the range of f of x is the same as the domain of f to the minus 1. And I'll highlight that as well. The range of f of x between 0 and 7. Yeah, again, notation there is f of x there. And then for domain, we just keep it still in terms of x. So that's just 0 to 7 as well. So these are really important points. Okay, so this key points here, there's a lot going on here, and we'll kind of go through each one individually. So f of x and f to the minus 1 x, they are inverse of each other. What this means is if we work out f of f to the minus 1 x or f to the minus 1 of f of x, we'll always get x. So if I take, for example, f of x is e to the x, then its inverse is natural log of x. Okay, e to the x and natural log of x are inverses. You can work that out as well, but we're just going to take that as a fact there. If I do f of f to the minus 1x, remember what that means is, from yesterday, I put natural log of x into e to the x. So this would be e to the natural log of x, which we should know from before. This just gives us x. And if I apply f to the minus 1 of f of x, yeah, again from yesterday, it means put f of x into f to the minus 1. Wherever you see x, you're going to replace it with e to the x. So if you do natural log of e to the x, it again, you also get x. Okay, there you bring the x. It's just 1. And that's just one example that will work with a variety of other examples. If, for example, you look at our previous one, if you replaced the x in f of x there, so if you place this x here with a third x minus a third, so you do 3 times a third x minus a third and then add the 1, you would get x. Alternatively, if you replace the x here with 3x plus 1, multiply it all out, you would get x. It's a really helpful fact that might be a key part of unlocking a really difficult question in the exam. It could also just be a 1-mark question at the end that they sometimes like to throw in, just like, oh, what is this? What is this a function of this? And you might just notice, oh, they're both inverses, so it's just going to be x. Second point is that that f of x and f to the minus 1 are reflections of each other in the line y equals x. That also can help with sketches and also just help with questions where you might be struggling with domain or range. I hope you just kind of see it from that question. Okay, or you might be thinking, well, I don't know how to draw that graph, but you might know how to draw the original. Okay, you might not know how to draw the inverse, for example, but you might know how to draw f of x. So you can just draw f of x and then just reflect it. So it's a nice way of being able to do that. And third point, the range of f of x is the domain of f to the minus 1, and the domain of f of x is the range of f to the minus 1x. Really, just learn that fact. Just say that over and over to yourselves. Print it off, put it on your walls, whatever. It's a really key fact to remember. It will really help you with these domain and range questions. Final point, in order to have an inverse, the function itself must be 1-to-1. So what you've noticed there, all the functions that we've looked at so far, they're not many to 1. There's not many values of x going to the same value of y there. All of these functions are 1-to-1. Next, what we've got is some preliminary questions to finish off. So this first one, so it's just a little bit harder to rearrange, I guess, but just remember a key thing, what happens when you've got multiple of the same variable that you're trying to make the subject, you want to try and group that together and then factorize. That's the key point here. So we start off with y equals 2x plus 1 over a minus x. So what I would do first is try and get all the x's over to one side So I'm going to have to expand a few things out here first. There might be other ways that you might get here, but I'm just going to expand everything out and then get all the x's over to one side, all the non-x's on the other side. Okay, so I've just added x, y to both sides. I've taken off -1 from both sides. That enables me to factorize out the x. And I'll just get x equals ay minus 1 over 2 plus y. As always, change your x to an f to the minus 1x and change the y to an x. By the way, sometimes you might see people, and I think actually it's in our notes as well, you could actually just change it in the beginning and do it that way. That's absolutely fine as well. Or sometimes people might just keep it like it is to begin with, or change the x to y to begin with and change the y to an x to begin with, and then put the function notation back in the end. As long as you get to that final answer with the correct notation, it's fine. We need to state the domain of this. So for the domain of this, x can be any real number with the exception of -2. So x can be any real number, but with the exception of -2, because then you'd have 0 on the bottom of that denominator, which would be undefined. So then for B, it says find the value of a such that f to the -1 of 3 equals 4. What this means is we've just worked out what f to the -1 is. So what we're going to work out is the following. So when I see that function, that inverse function, I'm just going to simply replace the x with a 3 and set it equal to 4. So with a bit of rearranging, we get 3a equals 21 and a just equals 7. For part C, find the value of a where a does not equal 0, such that f of x plus a equals f of x. So we would need to, so this is just kind of a bit of algebra here. Just going to make this a little bit smaller. A bit more room for this one. So wherever I see, so if we just start with the original function, 2x plus 1 of a minus x, put that on the right hand side. On the left hand side, it's just the same, but wherever I see x, I replace it with a x plus a. I'm then going to do a bit of expanding. And then I'm going to get rid of the fractions, so that's going to create some further expansions. Now, to save a bit of time, I'm just going to skip a couple of steps and just go straight to what you end up with, okay? Now, what we would do here is expand it out. What you will find is a lot of things cancel here. So we end up with 2a squared plus a equals 0. If you want to see the full expansion, look at the notes. So I'm sure you can expand that also. I just want to save time here. So we end up with a times 2a plus 1 equals 0. A cannot be 0, as you're told in the question. So the only solution is a equals -1/2. In terms of the comment, yeah, again, I don't want to overrun because there's one kind of extra example that we put in the notes here that's not actually in your booklet that I want to go through. So I want to go through that. I did make a little GeoGebra document showing what happens with that a. Basically, what happens is when a equals -1/2, it's just going to be a horizontal line. Okay, so f of x and f of x plus a is a horizontal line when a equals -1/2. And the reason for that is, if you think about it, if you have a function, so if you just have something like this, and then you apply a transformation f of x plus a, in this case a is negative, so it'd move to the right, well, you're going to get a different value. Okay, you put in a value of x, you're going to get a different value of y there, aren't you? Now, what happens though, of course, if it's just a horizontal line? Well, even if you translate that to the right, you're still going to get the same value of y. So that's why it would be a horizontal line. Last example then. And then there's just one little other bit in the booklet I just want to kind of touch upon. So apologies, quite a lot of me talking today. Just quite a lot of examples to get through. I just want to make sure we don't overrun too much. So I want to put this extra example in here because just show you what happens if we've got quadratic. Because it could be quite common that you find the inverse function of a quadratic. Now we've got x squared minus 6x plus 5, and we've got this restricted domain. We're going to talk about these restricted domains in a second. So if I've got this restricted domain, what I want to do first is complete the square. So I want to find the inverse, but I think the problem is I've got an x squared, I've also got a 6x there. So I want to make sure that I've just got the 1x. So I'm going to complete the square, because what this will help me do is when I try and find this inverse, now I only have 1x, so it's much easier to make the subject. So in this question, I'm going to let y equal tx. I'm going to add 4 to both sides. I'm then going to square root both sides. Now remember, you get a positive and a negative. That's going to be really important. I'm going to talk a little bit more about that in a second. And I get this as my inverse. So this would mean that I have the following at the moment. But why is this? So if you just put this, I'll ask this question in the chat. Why is this not a function at the moment? So why is this not a function at the moment? Yeah, sorry, I'm not. That's a that's a fair point. That should be an x there. Sorry, yeah. Obviously, that was the question I meant to mention there. So they're saying one to many. Yeah. So at the moment, this is not a one-to-one function. Okay. So at the moment, it's a one-to-many function. So if I sketched it, it would look something like this, where you've got many values of y going to one value of x, which we can't have. So what we need to do is decide whether this is going to be 3 plus the square root of x minus 4 or 3 minus the square root of x minus 4. Now, remember, my domain is x is greater than or equal to 5. What that means is the range of f to the minus 1 x is f to the minus 1 of x must be greater than or equal to 5. Remember, your domain is the same as the range of your inverse. So domain of f of x, or domain of t of x here, I should say, it's the same as the range of the inverse of t of x. So it always has to be 5 or greater. Now, the square root of x minus 4 is going to always be 0, or it's going to be positive. So therefore, if I take the negative here, well, it's always going to be a number that is 3 or less. Well, I know that my range has to be 5 or greater. So therefore, we need to take the positive version of this. So t to the minus 1 would be 3 plus x minus 4. Sorry, did I put minus 4? Sorry, this should be there, plus 4, shouldn't it? Sorry. Okay, sorry, that should have been plus 4s there. And you would know that the range of that would be greater than or equal to 5. Okay, yeah, sorry, that should have been a plus 4 there. Finally, there's just a little bit extra in the booklet. You might, I'm not going to go through this in great detail, but it's just something to watch out for. It's kind of what we just talked about there. So not all functions have inverses right away, as we saw with that example. So if you've got something like f of x equals x squared, well, that's a many-to-one function. So in order for that to have an inverse, we'd have to restrict the domain. So in that question, the domain was restricted to x is greater than or equal to 5. If you wanted to have x squared have an inverse, what we would do is restrict the domain to make that problem easier. Either what you could do is say that x is greater than or equal to 0, or x is less than or equal to 0. As you can see that when we do that, we'd have our graphs looking something like that, and we can see we've got that reflection now. So you haven't, if you look kind of where the symmetry is, and then you kind of restrict the domain either side, then you can now see that now it is just a one-to-one function. And the reason why it's a problem in the first place, if you think about it, if you think about, well, what is the inverse of 4, for example? Okay, if you find, well, what's for example, what is f to minus 1 of 4? Well, you could say it's either 2 or it's minus 2. So unless we restrict the domain, we don't have a definitive answer there. That's why they need to be one-to-one in the first place. So you need to restrict your domain so it is one-to-one. So just look over those key points. Apologies, there's been a lot of talking today. I know it's just a situation we're in that normally in a lesson I would let you then do a few problems in between, but we are where we are with this. Just a couple of things to look out for when you do the questions in a second. I posted this on the team. When you're showing that, so this show that question, you might see what you might see this word arcsine. What that essentially means is just, this is the same as saying inverse sine of x minus 1 over 2. And just think about it, sine x and sine to the minus 1 x, they are inverse of each other, okay? Just like cos x and cos to the minus 1. You'll see in second year that sine to the minus 1, you'll sometimes see that referred to as arc sine x or arc cos x. So it's just something I wanted to point out as you do the questions. Make sure that you sign up for the test, and